Hi there! On the bench today I have a highly collectible SONY CRF-320 communications receiver. Now this isn't your average everyday communications receiver. Sony really has done a couple of things to this to really make it stand out above the crowd here, and I'll get into those little features here quite shortly. So like all these SONY CRF-320 and 330K style receivers of this era, they all develop certain little issues that need to be addressed, kind of like any other old piece of electronics. So what we're going to do is we're going to address all these issues and bring this receiver back to its normal self. Maybe even do a couple of little extras to make it stand out even that much more. So let's get right into the video. If you're thinking of purchasing a SONY CRF-320 or 330K receiver, here's a few questions you may want to ask before making any buying decisions. The first question being, is this front plastic protective cover included? Many people seem to misplace or just altogether lose this front cover, and it's very important to have on the front side of this communications receiver during any kind of shipping or transport so that no damage happens to it. And of course, if you're buying one of these receivers to collect, you want to make sure that it's all complete. You also want to make sure that the battery doors on the rear of the receiver are included. Another question to ask is, does it have the factory line cord? This receiver has a really bizarre line cord. This end is not very common, and if the line cord isn't included, you're going to have a little bit of a search on your hands. So in order to remove this front protective cover, it's really simple. You just lift these two little clips like that, and it just comes right off. So the most common issue with these receivers is the gearing on these two shafts. The gear strips or breaks or just falls right off or slips, or there's a bunch of different failure modes. Now, I've never come across one of these receivers where both of these have been gone at the same time. It's always one or the other. And this one here is another of that same scenario. So this dial here is the medium wave and long wave bands. Medium wave just meaning the AM broadcast band, and the long wave band is below the AM broadcast band, so it goes from 400 kilohertz on this dial here down to 150 kilohertz. And you can see the gear on this one is okay. How you test these is you move them from side to side and make sure that the travel is smooth from side to side. A lot of the times it'll work well for a while, and all of a sudden it'll hit a spot and it binds up. This gear is a little bit rubbery feeling. I don't like the feel of it, but the gearing is still working on this one side. This is the FM broadcast band side, and as you can see, the gearing is completely done on this side. I don't know whether it's even in there or what's going on. It just seems to be freewheeling. So very common problem with all these receivers. I haven't come across one 320 or 330K style receiver that doesn't have a bad gear on either one of these dials. So that's really how common that is. I've only ever come across one Sony CRF-330K with a bad gear on this dial here. This one here seems to be fine. So again, you want to move this from side to side completely and make sure that the travel is smooth from side to side. This one here is absolutely fine. There's no problems with this dial. Another thing to look for is these pop-up antennas. These antennas here, they have a little spring-loaded pop-up here, and you press them down and you let them go, and you see how they kind of pop up, and that allows you to grab them and extend this telescopic antenna, and when you're done, you press it all the way down and give it a bit of a push, and it locks back into place. And this side is much the same. You do the same thing and lift it up. When you're done, push it back down. So you want to check those for functionality. A lot of the times these little pop-up antennas don't work properly as well. And that's really the only common issues with this particular receiver. All the rest of it after this is just whatever is happening to the receiver at the present time. So I hear the owner of this receiver says that it just isn't receiving on, I believe it's the shortwave band anymore, if I remember correctly. So we'll go through and check out the functionality of this receiver and find out exactly what's wrong with it, and we'll do some troubleshooting and bring this old Sony receiver back up to its regular happy self again. You sure are a pretty looking receiver. It's time to see what is working on this receiver and what isn't working. So another thing I just noticed is this S meter seems to be sticky. It's staying up around 3 there, so it's pretty common with this type of receiver, and there's a very easy fix to that, a little trick to it, and I'll show you that here when we get to that particular part. We also know that the FM, we can't do anything with the FM. So I'll turn this thing on, and give it some volume. Right now we're on medium wave, which is the AM broadcast band. And we can see this is working.
Enough to really make a compelling argument, but what about the reversal? 5-1.
So that's working. Let's see if the get a CW note. We do. Well, that's good. So we know that the CW and the lower and upper sideband seem to be operating. Let's try the long wave, which is the bottom band here. And that seems to be working as well. So the long wave seems to be working. Let's try the short wave, which is this side here. So what I'll do is give this some volume. RF gain is right up. And I'll move this around just a little bit. And we can see the counter stops at about this point here. And there's absolutely nothing through the rest of the dial down to the bottom here. So RF gain's up. Let's just get it to a point to where it's going to read here. And I'll touch both these antenna jacks here. And absolutely no change. Try the antenna tuning, move that around slowly. And turn the RF gain completely down. No change in the static level whatsoever. So there's definitely issues on this side. We can tell that just by this right here, the counter's going missing. So maybe a weak oscillator or something like that. I'll have to look into that. So this is not functioning. The S meter seems to have moved down to about 2 now. So I'll hit battery check. That usually bumps the meter up just a little bit. Now it's a little bit over 2. So I'll go back to medium wave here, turn the volume down. So I hit battery check. You can see it moves it up and then it gets stuck around 4 or something like that. So we can definitely see that there's a bunch of issues here. So a whole bunch of things to address, and this is really, we're just starting out at this point. So now what we're going to do is we're going to go inside this receiver and check out what is actually happening. I don't know if you can see in this light here, but whenever you select a different dial, it will light up green. I'll just turn the lamp off here and I'll show you that. Probably get a little bit of distortion because the lighting is low, but this is lit up green right now. If I go to FM, you'll see that it lights up a really dull green. And if we go over to the short wave here, it will light up a dull green. And we're going to also enhance that and make that look quite a bit better. This is really quite dim, even to my eyes. So there's a nice little modification to make this really, really stand out. So now we're going to go on to the inside of this thing and check out the inside of this receiver. To remove the front face or the front panel off the SONY CRF-320 is really quite simple. All you have to do is just remove all the knobs and take out these 4 screws, and this panel will come forward. And you undo 2 speaker wires and it should just come right off. Now before you go pulling off any knobs on the face of your receiver, you want to take a picture of it, so when you go to put it back together, you'll know where to put the knobs. There's a bunch of different sizes of knobs, and some have different colored markers than the other, and if you don't take a picture, you'll know what I mean when it comes to putting them back together again. So do yourself a favor and just snap a quick shot of the face of the receiver before you go pulling off all the knobs. You don't have to worry about these buttons here. These can stay and all of this can stay. It's really just these knobs here that all have to come off. And then just undo the 4 screws and it comes right forward. Another thing I didn't mention, and it's really quite common for these to be missing, is these little doors here that slide up over the settings for the clock. They are missing quite often. That doesn't affect the performance of the radio at all in any way, shape, or form. It's just really there for aesthetics. And as you can see, this one here has 1 missing door. So it's really quite common for these things to be completely missing. So another thing to look for if you're going to purchase one of these receivers. Once you've removed all the screws from the front side of the receiver and the knobs, it's relatively simple to get in. So I've left this one knob just on the top here to hold the face from falling forward. So I'll remove this knob, put it on the top, and you just tilt the front forward. Since the bottom of the front panel is in a lip in the bottom, you just lift it up and over, bring it forward, and undo these two speaker wires here, and you can completely remove the front panel from the receiver, and you're into the front here, and you can do whatever servicing you need to do at that point. And of course, the reason that we need to be in the front is we need to get in here and see what's going on with this gear. And just for general troubleshooting and for general servicing, it's handy to have the front off because you can go back and forth. Looking at the rear side of this SONY CRF-320, getting the back off is just as easy. It's just a bunch of screws. One here, one here, one here, one here, and one here, and the whole thing will come back like this. It's really quite easy to get off. There's no hidden screws in the battery doors or anything like that. And behind here is where the clock battery goes. There's a D cell here and a little storage compartment for the power cord. And down here is where the D cells go. And we can see the decaying foam block here. You can see that decaying foam block that wedges against the batteries. But there are no hidden screws inside these little battery cases or anything like that. So it's just really what's exposed. These screws here do not need to be undone to get the rear off, and you don't need to undo any of the screws here or here. It's just these ones right here that will allow you to remove this rear panel. It's just that easy. Once you've removed the screws, as mentioned earlier on the rear panel here, and there are also 3 screws that I may have neglected to mention on the bottom side of this panel here that you're going to have to undo. It's closer to the front of the radio. This rear panel is ready to come off. So you're going to get the rear panel about so far away, and then you're going to have to undo a wiring harness that's right here. That is the power supply for the clock. And then right at the bottom there's another 2 wires down here that are on the inside that connect to a circuit board, a red and a blue wire that you'll just need to pull off their own clips. And then this rear panel just comes off like so. Now, before you want to really do any kind of repairs on this radio, I've noticed throughout time that these foam blocks look like they're moldy, and I'm not sure what that is in that foam block, but it really looks like mold. So I don't take any chances. What I do is I take this into a well-ventilated area and I remove these blocks. So really it's like a piece of foam stuck to a piece of tape, which is then adhered to the circuit board. So if you get the foam off, you'll notice that there will be a tape residue left. You'll have to remove that residue. There also is another foam block down here, but this one looks like it's been removed already by somebody else. And of course the 3 screws on the bottom panel, or on the back side, the bottom panel is a part of the back here. They were also missing. So somebody has been in here, it looks like, and they've tried to do some servicing already at some point in time. So once you get the foam removed and everything, you're pretty much ready to do your servicing at that point. Just before I go about removing this foam, this is kind of interesting. I've poked my probe leads in here. Alright, so I'll move this up here. Now watch what happens when I poke this lead into the foam. 36 megs. Remove the probe lead, poke it in up here. 34 megs. So I'll poke it really close to this other probe, 20 megs. So the foam is actually becoming conductive as it's decaying. So where the little legs of the components are poking through the back side of the circuit board here, and they've soldered them, if those little legs are poking into any of this foam, it could be making continuity between some traces. Of course, the resistance will be quite high, but still, that can affect some circuitry. So these foam blocks are definitely a very big issue, so they definitely have to be removed. Alright, I've got rid of all the mold now, and that was in that foam in the back. Now I've noticed that in these receivers, it just seems to be that block of foam, that one and the other one. I noticed that there's foam in this lip here still. I haven't got all the foam out because I have to remove the bottom of the radio to get the foam in this lip. And the foam that's on here didn't seem to have any mold in it. It's just those blocks. So I don't know why it always seems to get trapped in those blocks. Definitely is mold, and in one spot it was even black. So when I removed all that, of course I did that with a proper mask on. And then when I was done with the mask still on, I went outside and I blew the chassis out with compressed air to make sure that it's all gone. So now we're at the point where we need to start troubleshooting this thing. If you recall earlier, it seems like the shortwave is pretty quiet and the frequency counter kind of stops counting midway. So we'll turn it on here again. You can see there's just decimal places there. I don't know if you can see that very well with the light. Let's move the light a little bit. So there's just decimal places here. And then when I move this, you can see that there's pretty much no action on the VFO or in the VFO at all until I pretty much come right to the end. Then it starts at 0. And technically the 0 should be at this end. So this is kind of pointing towards this area here at first. So now what we're going to do is we're going to take a look at the block diagram and the schematic and figure out where we need to start looking first to start troubleshooting this issue. Now that we've run some preliminary tests, we can use this block diagram to get an idea of where we need to start looking for some issues. So we know that the medium wave and the long wave works just fine, and we can see the antenna path goes all the way through here into this medium wave, long wave RF amplifier and out to this point right here. Yet we know that the short wave doesn't work at all and the display is acting funny. So this is the short wave antenna path. It runs in through here, through the shortwave RF amp, through a bandpass filter, through a balanced mixer, and then through our shortwave IF amplifier right here. So since the receiver is working on the medium wave and long wave, we can pretty much say that everything past this point is working. So it's something back here in the short wave. And it also extends down here into the synthesizer and all the way over into the frequency counter. So we actually have quite a large area to look. Now, you'll notice that when we turned the VFO dial, we only had a little bit of action right at one end. Now, it says right here that the VFO goes from 2.455 megahertz to 3.455 megahertz. I'll just zoom in on this a little bit here. So you can see here, this is the VFO right here, and the VFO really just goes through a buffer amp and then directly right into the frequency counter. So this should be relatively easy to check. We can check the VFO just by undoing a connector that runs into the frequency counter and then taking a look at it on an oscilloscope. And that will really be the first thing that we're going to check, because this is suspect. It goes, pretty much all the way to one end, and then all of a sudden we get just a little bit of a reading. So we don't really know if this frequency is falling within the 2.455 megahertz to the 3.455 megahertz range. So this is the first thing that we're going to check. Okay, so here we are on the back side of the radio. And this is the VFO, and we have a cable coming out on the top here, and we also have a power lead right here and a cable coming out on the bottom. This one here runs out to the synthesizer, which is this big box on the bottom here. Alright, so since we have this cable running out on the top here, we can see if we follow it, it goes right up into the counter. So there's a small plug there that runs up on the counter. So that's the plug that's right at the front. I'll see if I can get a little bit better, there we go, a little bit better shot of it there. So you can see this one here, this one right here is the VFO in, this one here runs out to the synthesizer. So this is the one that we are going to focus on. So what I'm going to do is I'm going to remove this plug here, and we're going to take a look at the VFO output and see what kind of signal we have on this connector right here. I now have my oscilloscope tied to the VFO output here, and I'm using a 22 meg resistors leads just to tie into the socket here so I can make connection. And this works quite well for this particular application and other applications where you have these little connectors here. Now, if you ever do this yourself, you want to make sure that the leads aren't too big. If you ever find that you're forcing the resistor into these sockets, you'll stretch the connections in here. And then when you go to remake the connection to wherever this was plugged in this case, this is going up to the frequency counter, you might have a loose connection. So they should just fit nice and snug, and you shouldn't actually have to force the resistor in. So we're ready to take some measurements here. We'll take a look at the scope, and I'll just turn this on right now. And that's the signal coming out of the VFO. So we can see that we're down at the low end, 2.42 megs. I'll just turn the VFO dial here, right to the opposite end, and we can see that it is oscillating and it is within the correct range. So this is the top end, 3.47 is pretty much where it's stopping. So it is traveling through the area it's supposed to travel. All right. So now what we're going to do is we're going to take a look at the stability of the actual signal coming out of this VFO. I'll actually hook this to a counter, and we'll take a look at the counter and see if we have any digit movement or if it's unstable or anything like that. It looks pretty stable on the scope here. I have the frequency counter hooked to the same 22 meg resistor that the oscilloscope is hooked to. And as you can see, the amplitude of the waveform has dropped just a little bit. It was at about 500 millivolts peak to peak before. Now it's at about 330 millivolts or something like that peak to peak. And that's just because the frequency counter is loading the circuit just a little bit. So I'm not really too concerned about that. What I am concerned about is frequency stability. So let's take a look at the counter and check out the actual stability of the frequency coming out of this VFO. So pay no attention to the movement in this digit. We're not really worried about that. To give you an idea of how sensitive it is at this point, I could dangle a piece of Kleenex on the VFO shaft and it would cause massive movement in this digit. So we're not concerned about that. That is extremely stable. So right now we're at 3,391,977 cycles per second, or in today's speak, 3.391 megahertz. So very, very stable VFO. It's just a free running oscillator. It's doing very, very well. So now what we want to find out is if the amplitude coming out of that VFO is enough to actually drive the counter. That's going to tell us quite a bit. So what I'm going to do is I'm going to hook a function generator up to the input of the frequency counter, and I'm going to mimic these frequencies, and we'll see if the counter does the exact same thing it does with the VFO. And then what I'll do is I'll up the signal level running into the frequency counter, and if it still does the same thing, we can be pretty positive the problem is somewhere else in this receiver. I've now got my function generator hooked up to the input of this frequency counter here in the Sony receiver. So my function generator is just taking the place of this VFO right here. This VFO is completely unhooked right now. When you look at the display here, you only want to pay attention to these three digits. These three digits are the only ones that are actually controlled by the frequency counter. The first two digits are controlled by these two knobs right here. The factory VFO goes from 2.455 megahertz to 3.455 megahertz, so really it has a 1 megahertz span. I have my function generator sitting at 2.455 megahertz, and I'm getting a display of 335 kilohertz, which is telling me that there is something else wrong within this receiver, and I'll touch on that here in just a moment. So since I'm sitting at 2.455 megahertz, let's see what happens when I change this to, say, 2.6 megahertz. We get a display of 150 something kilohertz. Let's try a 2.7 megahertz. 023, and if I go to 2.8, it'll probably be out of range, and it is. So this should still be reading all the way to 3.455 megahertz. And when this is sitting at 2.455 megahertz, this should be sitting at an end, not at 335 or whatever kilohertz. So now I know the signal that's running into this frequency counter is very accurate, but in order for this frequency counter to know how to count, it has to have a reference oscillator. So that really is the only thing that's telling this thing where to be, aside from maybe a programmed offset. So that really is the next suspect. This is the schematic for the Sony CRF-320. And what we're looking for is the reference oscillator, and the reference oscillator is right here. So it looks like they're using a 74LS00 as the oscillator, and there's a crystal right here. So the signal's running out into this buffer through a division chain and then out to this number 1 here, and you can see there's a hook in the wire, so that means you follow the wire this way. You go all the way over here. You can see that there's a number 1 there. You follow it all the way up here, right into the frequency counter board. So that's the reference for the frequency counter. So that's definitely suspect, and that's what we're going to be checking next. Now, this is the synthesizer area, and that's that big block that was bolted into the bottom of the receiver. So we'll have to get into there. So I'll have to take the sides of the receiver off and pretty much disassemble the entire receiver to get this out. So what we just looked at was the VFO. This is the VFO here, and it has 2 buffers in it. So one buffer runs this line here. This is the line that we tested. And the other buffer runs out here. It says V, and it hooks down here. So we follow this here, all the way over here, and into here, which is a bandpass filter on the other side of this mixer. So that runs all the way up over into here. So this is what we just looked at, and the VFO seems to be working okay. And then, of course, when we fed that signal in from the function generator, it pretty much acted exactly the same way. So this section here right now is definitely suspect. So what we're going to do is we're going to take a look at all of this area next. Here's a shortcut to get in at this bottom hinged panel just a little bit easier. So what you do is you remove this foot on this side, you remove the foot on the opposite side of the receiver, and remove the bottom panel. Remove these 2 screws on the side panel and lift the side panel up just a little bit, and that'll allow you to get in at this Phillips screw that's right here. Remove this Phillips screw and the Phillips screw on the opposite side of the receiver in the same area, and then all you do is just hinge this open like this. So this is the synthesizer right here, and in order to get in here you have to remove a few screws as well on the cover. So this is the cover for the synthesizer. So in order to get this cover off, you have to unplug this connector right here. So you unplug that connector and then undo the screws on the top cover here, so the screws all the way around. And once that's removed, you'll come to an RF gasket, and this is the RF gasket that sits underneath. So what you do is you desolder. There's 2 capacitors soldered to this little tab on the RF gasket. Just desolder that, and this will just come right off, and you're into the synthesizer unit just that easy. Now that I've got the bottom portion of this receiver swung forward on its hinge here, you'll notice in the receiver there's this long shaft with a foot on the bottom of it. This shaft is connected to the power switch on the front of the receiver, so when you turn that power switch, this shaft moves up and down. So this foot presses on this switch right here, and that turns on the power supply. So in order for me to troubleshoot this synthesizer, I need power applied to it. So what I'm going to do is take a piece of tape and put it over that, and just to hold that switch on so that I get voltage to the synthesizer area. Now, it's not good enough just to have this piece of tape here. You also need the switch in the on position. There's another switch on this shaft at the opposite end that needs to be in the on position for everything to work properly. So if you're going to be defeating any power switches or working on any receivers with any power applied to them, you're doing so at your own risk, so just take care. So there still is no power applied to this receiver. This is all hooked to a master switch that I have on the wall. So I have to turn on that master switch to supply power to this entire receiver. So right now everything is still off. Now this is the synthesizer area right here. And I'm going to focus in on a small area here. And you'll see, if I can get my light on that, you'll see 5 kilohertz out right here, and that's on this pin right here. So we should have a 5 kilohertz signal on that pin. So what I'm going to do is I'm going to take my oscilloscope probe lead, attach it to here. It's fine to attach your probe lead to the chassis here. This is the common lead. And I've got the probe hooked up to that now. So let's take a look at the oscilloscope. Just move this out of the way. And I'll turn the power supply on. And it says we've got 980 hertz, and that's not the signal that we are looking for at all. So I'll just shut this off here. I'll remove this probe lead from here. So if we look back at the synthesizer here, you can see there's an IC that says UPC 1008C there. So if we look at the actual sheet that comes in the service manual here, you'll notice that we have 1, 2, 3 ICs right here. So this is the service sheet, so in order to look at this, we'll turn it sideways, and that mimics these ICs right here. But you'll notice on the sheet that we have an MC4044P, whereas this one is a UPC 1008C. So obviously somewhere down the road they've subbed that IC for this one, or vice versa, maybe for an important performance improvement or less noise or something like that. I really don't know. But pin 1 is the output on that IC, and pin 1 is the output on this IC right here, and they show it going through a resistor and a capacitor right into the frequency counter. So we're using an oscilloscope to look at this, so it should be absolutely fine. We really won't need to do this. I have a 10-to-1 probe on my scope. So what I'm going to do is focus back on the oscilloscope here again. I'll grab my probe lead. Alright, now what I'll do is I'll turn the receiver back on and I'll touch this to pin number 1, and we should have a 500 kilohertz signal here. And that's on pin number 1. And there's absolutely nothing there. I'll see if I can move the camera slowly and show you. Alright, I'm touching pin number 1 right now. And absolutely nothing there. So we can definitely see that we have problems within this synthesizer unit. So the next thing to do would be to look for supply voltages in this unit itself to see if there's actually any voltages present in here, because it seems like there's quite a wide area with nothing happening. We know that 2 signals that we've looked for on this synthesizer board are not here. So what we want to do is we want to check the supply voltages coming to this board and make sure they are. Now, the supply voltages come into this area here through these terminals right here, and Sony was nice enough to mark on the circuit board 5 volts, 6.3, and this runs off to an area that says 12 volts. So what we're going to do is we're going to check to make sure that those voltages are present. Alright, so here we have, there's 11.6 volts here. We have 4.8 volts here, and we have 6.3 volts here. So everything is there that should be there. So the next thing we want to do is we want to make sure that those voltages are present on these ICs right here. And 74 series logic ICs have a pretty standardized system for their positive and negative supply pins. So this is a 16-pin IC. So that means that pin 8 is negative and pin 16 is positive. Now this is a 14-pin IC right here, and the positive and negative pins on this IC are the same as a 74 series logic IC. So since this is 14 pins, pin 7 is negative and pin 14 is positive. So one really easy way to remember this for these ICs is the pin directly across the IC from pin 1 is the positive supply. And then if you follow on the same side from pin 1 right down to the opposite end here, which is pin 8 is negative. So it kind of goes on a diagonal. And this is a pretty standardized system for 74 series logic ICs. Now these early 74 series logic ICs run on 5 volts. So that 4.8 volt supply that we saw there should be on these ICs. So what I'm going to do is probe the pin here, pin 16, and we'll take a look at the voltmeter and we'll see if those voltages are present. Alright, so here I go. This is pin 16 here. And we only have 0.5 of a volt present on that pin. So we know that we have a supply voltage missing there. And this is the supply pin here for this UPC 1008C. So what we're going to do is probe that and see if that voltage is there. So here we go. And again, we only have about 0.5 of a volt on the supply for that IC. So now we know that we have an issue between this area here where the supply leads are coming in and the supplies for these ICs. So I'm imagining maybe an open solder joint on the circuit board or a burnt trace on the back side or something like that. Now if you look over here, right here is where the 5 volts runs off of this board and onto this board here. So all the supplies, they all come in right here. So they all have to carry through these boxes. So if we look here, obviously the supply is going to have to come through here and down here. This is where that 12 volt supply comes in here. And then of course all the voltages will have to carry on down through here and right down into here, and you can see it says 5 volts there as well. So we can kind of tell that the 5 volts is kind of carrying through here like this. So what I'll do is I'll probe this pin here and I'll see if that 5 volts is present there. So here we go. And again, there is no 5 volts present there as well. So that would explain why not only is the frequency counter not working, but the entire short wave section is just not working, because this here is all part of making the receive section work, not only just making the frequency counter work. So the next thing to do is to remove this circuit board here and find out where the issue is. The synthesizer board here is now removed from this housing, and getting the synthesizer board out is a little bit of a pain, but if you need to service it, you've got to get the thing out. So the very first thing to do to remove this is, you'll notice that there's a little ground tab here. Alright, and that's very easily overlooked just because it's kind of hiding and it's pressed right tight to the box here. This has to be desoldered from this terminal tie area here. There's a bunch of feed throughs on this terminal tie area, and this feeds the voltages into the box, and there's also a signal present on one of them. So this here fits into here like so. So the terminal tie area fits into this little machine slot, and they've soldered this tab right here right onto this terminal tie board. Now it's right on the aluminum, so when you go to desolder this, some of your solder is bound to touch this aluminum here, and it's going to sink the heat off your iron. So you're going to need to have a really hot soldering iron, and what you want to do is have a jeweler screwdriver, and once you heat this up, slowly feed a jeweler screwdriver under there and then pull this away from this board here. This board will not come out if this is soldered to it. So now what they've done is they have a bunch of little tabs in here that tension this into this machine slot here. So in order to get this board out, of course you're going to have to remove the screws first, and you need to take these 3 wires off. So now you want to mark these. If you haven't marked them, this one goes to a terminal called N. This goes to 5 volts. The red one goes to 5 volts. And the black one goes to E, or earth. So once all the screws are removed, what you want to do is you're going to have to pull on this tab gently. You don't want to bend the circuit board, because the circuit board ties to these, and a lot of the times these things are ceramic, and if you bend them, you're going to crack these feed throughs. So you have to kind of work at the terminal tie board and kind of work it out in an orderly fashion, and it should come right out. They've put a capacitor with some glue right over the top of this screw, so you're going to have to pull that capacitor forward to get to this one screw here on the inside of the box here, right at the top. So once all that's done, you have this board out and ready to be serviced. Before I start working on this synthesizer board or troubleshooting it, I want to make a few observations. And these observations are very crucial whenever you're doing troubleshooting, especially in something like this. So basically what I'm looking for is I'm looking for tampering to see if any other tech has been in here before me. Has that tech done anything stupid? Have they screwed up on the assembly line? I want to put this big picture together before I start working on this circuit board here and then start adding my fresh solder. Once you start adding your fresh solder, it becomes very difficult to trace backwards, because now, of course, I've tampered with it at this point. So the things I'm looking for right now are, here's an example. There's a lot of dull solder on both of these circuit boards, even on the main circuit board over here. There's a lot of really dull solder, but there is a lot of very fresh looking solder joints, and there is still resin residue around those solder joints. You can see the resin residue there. Now this board is a pretty healthy mixture of shiny solder to just dull solder. So this particular unit didn't look like it's actually been tampered with. You can see I've removed all the screws on the case. Obviously I've got to get the lid off to get at the circuit board, and all the screws that were holding the lid on have almost like a lacquer or a paint on them, and that paint didn't look broken, so it didn't look like any tech has actually been in this module. Now this is a pretty deep place to get inside this receiver. This by no means is easy to get into and to get this board out, as you can see so far. So what this is telling me is that chances are when they were assembling these circuit boards on the assembly line, they probably had a quality control worker there looking at the soldering connections, and anything that looked a little bit sketchy they would just go over and resolder. So this is most likely the reason for this mixture of shiny to dull solder. There is actually quite a bit of shiny solder on this board. Now, and I can even see that they've left the resin residue around here. Now, if it's you know, an R or an RA type flux, that's not going to matter. As you can see, this board's got lots and lots of time on it, and it hasn't done any corrosion or anything like that. So those are the first things that I really want to look for. Now, there's another thing here that kind of does throw a wrench into the gears just a little bit. You can see here where they've soldered the wires to these terminals here. Well, you can see this orange wire down here is laying right up against the frame here, up against the negative, and this is a 5-volt line. So you can see that I can pretty much just move it. It's held on by really just a piece of solder, and that was laying up tight against the ground here. So obviously not touching, because if it was, it would take a fuse out or, you know, short out the 5-volt supply. But that is, you know, some pretty interesting work. I don't know if that would be from the actual factory or not. Maybe somebody just overlooked something and, you know, that just got tacked on there very fast. Now this is on the 5-volt supply, but this wasn't causing the 5-volt supply to go away. As you saw, we did have the 4.8 volts at this terminal here, so there were no shorts, and the problem would be within this board somewhere. So just a couple of observations before I actually start working on this. And this thing is also littered with this glue, as you've probably seen before. They've got this glue on it, but it is not conductive. There's some of the glue down here they've used. You can see that glue right there. It is non-conductive. So I always test this stuff. When it gets to this color, if it's that glue that goes conductive, it would definitely be conductive by now. Now I've gone through the entire radio, and this whole radio is just littered with this glue. Like, this glue is everywhere in here. And thankfully, that glue is non-conductive. Now those foam pads, yes, they were very conductive. But thankfully, again, that the glue is not. So now we're going to get on to the troubleshooting of this board, and we're going to find out why and where that 5-volt supply is going missing. Now that the synthesizer circuit board is removed from this housing here, the 5 volts is making connection to the board again, so that's telling me that there is an intermittent connection somewhere here on the circuit board. In an attempt to find that 5-volt intermittent connection, I've soldered a wire here to a non-intrusive portion of the 5-volt supply, so really that would be far away from the problem. And I've also soldered another wire here to the input of the 5-volt supply, again far away from where the problem could possibly exist. Both those wires run up here to this small curve tracer, and really what this curve tracer is doing is it's acting as a very sensitive ohms meter. So basically, if I flex or tap the board, any slight movement of a solder joint that might be making an intermittent connection will show on this. This thing will just start to twist and jitter and do all sorts of things. Now, just removing this circuit board from the actual housing here has reestablished that connection so well that flexing the board and knocking it with a plastic screwdriver makes absolutely no difference in this trace here. It just stays rock stable. So what that means is, since that intermittent connection is hiding, I need to resolder this entire circuit board. So what I'm going to do is remove all this old solder here and completely resolder the circuit board. And while I'm in here, I'm going to also replace all the electrolytic capacitors. There's also some hiding underneath this can here. The synthesizer circuit board is now removed from the Sony so that I can inspect this and work on it just a little bit easier. I'm going to recap this entire circuit board and of course resolder it, and I have to remove this can here to get at some electrolytics that are hiding on the underside of this can here. So one thing to keep in mind when you're working on these circuit boards is that there are no plated through holes. So if you remove an IC or anything like that and you see a connection on the top side of the board, you probably want to solder it on both sides. If not, you're going to have some pretty bad results in the end. What they did with these boards before plated through holes is wherever there is a via, they put an expansion pin in or just a piece of wire, or even the pin of the IC will just act as a via. So that brings us to one of our very first problems, which makes me wonder if this board has ever really worked properly. You may already see the issue. If you see this UPC 1008C here, you can see that there's absolutely no solder on this pin here and no solder on that pin right there. And there are no connections on the bottom side between those two pins. So this could pose a really big problem. So I'm thinking, maybe that these two pins are just unused or something like that. All right, I'm imagining that there was a via between the two or something like that. So I grabbed the schematic. And this is the equivalent to that IC. So if we look at pin 13 and pin 4, there's definitely a jumper between the two. So here again, absolutely no solder on those two pins. Now, if I look really closely at the board, the IC is standing off the board just a little bit. All right, so when you look at the pins on these ICs, this is what they look like. All right, you can see that they kind of have a taper and they come down right to here. Well, if this was, maybe pressed right onto that trace really hard, it may make a temporary connection, but any kind of oxidization is going to cause a really big issue, especially if this isn't sitting flush. So if this was sitting, right down to the board like that, but if it's sitting up just a little bit, there's going to be absolutely no connection. And that IC is actually sitting up just a little bit on that board. So that's one really big issue that needs to be addressed. And then of course I'm going to need to get under this can here to replace the electrolytics. And in order to do that I need to desolder all this here. And I need to desolder these blobs here, this blob here, and I think there's one also hiding under this braid here. And then I'll be able to remove this can and get at the electrolytic capacitors under there. So there's quite a bit of work to be done on the circuit board to make it acceptable. While I'm here, I'll clean off all the glue and stuff that's on these pins just because it'll be available. Again, this glue doesn't seem to be going conductive, but wherever it's touching some IC pins or something like that, it wouldn't harm to get rid of it anyways. I've removed the UPC 1008C from the circuit board here just to see what they've done on the underside. And what they've done is they've run a solid wire jumper. That would explain why the IC is lifted just a little bit. The plastic case of the IC is laying right on this solid wire. So what they've done is they've soldered this wire on the bottom side of the circuit board, run it up to the top side here and back to the bottom side, and they've soldered it again. The reason they've done that is because, again, there are no plated through holes in these circuit boards. So they've probably done this because they can't get the soldering iron in on the top side here. It's probably just a little bit too tight to all these components. So they've just made the connection on the bottom side. So this has mildly restored my faith in this circuit board. On this side of the circuit board is the reference crystal. It's a 500 kilohertz crystal. This is the trimmer for the crystal, so this is a variable capacitor, and they're just using a 74LS00 as the oscillator right here. So I've got this can removed because I want to replace this capacitor here and get rid of all this glue and everything. And of course I'm going to resolder this entire circuit board. So because I'm going to resolder this entire circuit board, I'm going to move some things around in here. So I'm going to need to readjust this trimmer capacitor when I'm done. So this will be reinstalled in that shielded box that we removed this from. And at that point I'll readjust this capacitor for exactly 500 kilohertz. The synthesizer circuit board is now done. So I've recapped the board here. Not many caps, only about 5 caps here. Also replace this electrolytic under here. It's glued to the top of the IC just like the previous one was. This one's sticking out on an angle like this because there's a screw that needs to be installed here, and the factory one was the same way. You just kind of fold it and tuck it in when you're done. So I've left the lead length a little bit long here. I've resoldered the top side of the circuit board, and I've also removed all the glue from the top side of the circuit board. The only glue that remains is on this yellow wire here. I've completely resoldered this entire bottom side of the circuit board, so that was really quite time consuming. Reason being is I completely desoldered this board first before I resoldered it. And then when I was done resoldering this entire board, I removed the RA flux with lacquer thinner, and this is the result. So it looks better than factory. Lacquer thinner works very, very well for cleaning off circuit boards. You just have to be careful that you don't get any of it on the capacitor shields or anything like that, because it'll remove all the writing. If you do use lacquer thinner to clean a circuit board, you want to do so in a very well ventilated area, and you definitely don't want to have any flame or anything close by. That stuff is very flammable. Now you'll notice that there's a little piece of braid missing here, and there was a little shield that went under the braid to stop the braid from touching the pads here. That's missing, and the reason that it is missing is because this trimmer capacitor here is what trims up the reference, and this trimmer capacitor with this fixed capacitor on the bottom really sets the range of this capacitor here. Now, this board is old enough that this is probably out of range, so basically the capacitor will be at one end. I'm not sure which end it will be at, but they usually always are. And of course the fact, since I've removed this and completely resoldered this and moved components around, it's a good idea not to install that braid. That braid would cover up this capacitor here, and it would also cover a large area here. So before I end up putting this little braid back on here, I want to make sure that this will come on to frequency quite nicely, which involves us testing this circuit board outside of that box. So if this is out of range, I'll need to adjust this. This is a 22 picofarad capacitor. So depending on which way, if it is out of adjustment, I'll either have to go up or down with this to bring this capacitor back to where it should be. Now, how they set these things up at the factory, this thing here is hand selected. All right, this is put on here by hand by somebody on the line that's actually testing this thing before it gets put in that box. And they have a set criteria. They take a whole bunch of things into account when this is pressed into the box. Is that going to add any capacitance? If that braid is put over here, is that going to add any capacitance? If so, how much? And then of course this is all taken into consideration before they choose this. So when this thing is on the assembly line, they want this thing to start out basically half ganged, or half meshed I should say. All right, so this little capacitor in here this is like a very large version of that capacitor. All right, and of course this, the one inside the box is much smaller than this, but this just represents that capacitor. So of course when this is fully meshed like this, say this capacitor goes from 0 to 100 picofarad. This would be 100 picofarad, and this would be 0 or very close to. And then of course if it's half meshed like this, it would be 50 picofarad. So basically what happens is when they start out these capacitors here, they're half meshed like this. All right, so you have the ability to adjust it either basically to add capacitance or remove capacitance. So what happens is since this is half meshed like this, what they do is they trim this capacitor on the back here. So they'll try a bunch of different capacitors, or again their criteria will help them choose this capacitor. They get it as close to 500 kilohertz as possible with this half mesh, so that when they put this in the box, they've got a lot of leeway either way to adjust this. And that's really what this does. So with this capacitor on the back side like this, and this thing half meshed, this thing should really be just as close to 500 kilohertz as absolute possible. Now again, because we've moved everything around on this board, and of course I've resoldered this entire board, and this has got quite a bit of time on it, there's a really good chance that this thing is not at 500 kilohertz, and it may not even align to it. So before we go putting this back in the box and hooking up all this wire and doing all this kind of stuff, we want to do some preliminary tests first. In order to test this synthesizer circuit board on the bench, I need to make sure that I'm going to give it the required voltages in order to make it operate correctly. I also want to check this 500 kilohertz oscillator here to make sure that this is as close to 500 kilohertz as possible with that variable capacitor half meshed. If it's not close to 500 kilohertz at a half meshed capacitor, I'm going to change that fixed value on the rear side of the circuit board. Now you can see here it says 24 picofarad, and you can clearly see on the rear side of the circuit board that they have a 22 picofarad capacitor here. And that again is because that capacitor is hand-picked at the factory. Now the reason I want this half meshed is because down the road that allows for adjustment in this oscillator. All oscillators will move with time, and this will just allow the person that owns this radio to have this section adjusted again if the reference oscillator does move. It's just good practice to do that. If I was to say just trim this up to 500 kilohertz and say that capacitor was almost fully meshed, there would be no room to adjust it anymore after some aging again. And then of course the board would need to be removed from the radio again, and you'd have to flip it over and adjust this value here, that fixed value on the rear side of the board. So Sony's been nice, and what they've done is they've pretty much run this entire circuit board on a 5-volt system. So the 74 series logic oscillator I see here is at 5 volts. This whole division chain is at 5 volts. Yeah, you know, all the logic here, the MC4044P or the UPC 1008C, like that's on this circuit board here, is all at 5 volts. So it makes this rather easy to test. They say 4.8 volts here on the schematic, but it's marked 5 volts on the actual board. And when we did measure it earlier, it was at 4.8 volts. So the first place I'm going to test is right here with an oscilloscope, just to make sure the board is actually running. So this is a 5 kilohertz point here. So I'll put the scope here and I should have a 5 kilohertz signal at this point. And that'll tell me that this whole entire chain here is working and this entire oscillator is working. If this is all running at that point, then the next thing to do is to set this oscillator on a frequency counter and check its range. The terminal we're going to be using to power up the circuit board is this one right here. This supplies 5 volts to the board. I'm going to ground my power supply to this point right here. This is grounded to the entire board. And on the other end of the circuit board is where we're going to test the frequency. It says 5 kilohertz out right here, and this is E for earth, so this is ground. So that's what we're going to do right now. So I'll attach my scope probe. And I'll hook up the power supply, so I'll just ground to this tab here and put the supply to here. Alright, now I'll turn the power supply on in the moment of truth. Here we go. There it is. 5 kilohertz at 5.1 or something like that volts peak to peak. So now what we need to do, now we know that the circuit board is actually operating, we need to check that oscillator for accuracy. Just seeing 5 kilohertz isn't good enough. We need to actually go to the 500 kilohertz oscillator and see how many zeros we can put on that 5. I've got the synthesizer board on another bench here hooked up to a different 5-volt supply, and we're going to be using this Hewlett-Packard frequency counter to measure the reference oscillator frequency. So the signal is present at pin number 1 of that UPC 1008C. So I'll pick up my probe here and I'll touch pin number 1 of that UPC 1008C very carefully here, and we should have 500,000 with as many zeros as we can get. So here we go. Alright, so we're at 500,011 cycles. So of course we don't want 11 there, we want all zeros. So I'm going to insert a tuning screwdriver through that little hole in the lid of the reference oscillator, and I'm going to turn that tuning capacitor. So here we go. It is coming down. and that was the point of maximum capacity there at about 4. Yep, that was the point of maximum capacity. So I'll just remove the probe here. So what that means is since that's at maximum capacity and we have a 22 picofarad capacitor on the rear side of the board, I'm going to need to take that 22 and probably change it to a 33 or a 39 picofarad. So when the frequency is high, adding capacitance will bring the frequency down. When the frequency is low, reducing the capacity will bring the frequency up. And again, I want this so that that variable capacitor in there is about half meshed around 500 kilohertz. So it should go a little bit below 500 kilohertz and a little bit above in order to be acceptable. So I'll remove that 22 picofarad capacitor and I will install a 33 and we'll try it again. Really, that is a trial and error thing because you really don't know how much capacity you need to add. So I'm just going to step it up to 33, and if not, 39 should definitely be past the point. I've changed out the capacitor on the bottom side of this board, and believe it or not, I've changed it with a 22 picofarad capacitor. The one that was in there was reading a little bit low. The one that I replaced, it was at 20 picofarad. So putting a 22 picofarad capacitor in there, and there was also a 30 picofarad capacitor right in series with the crystal. I added 3.9 picofarad in parallel with that capacitor. And I got a pretty linear sweep from 5 above to 5 below. So I'll just demonstrate that right now. I'll power up here. Alright, so here we are, pretty much right on frequency. So I'll turn this one way. And you can see I have 5 above, and if I keep turning it, I have 5 below. And that's what I wanted to achieve. So right when the capacitor is half meshed, it's right at 500 kilohertz. Now I'll have to set this when it's in the box because the circuit board's out and I'm flexing it with my hand and everything. I'll just remove the probe here. I'm flexing it with my hand and everything, and nothing is screwed down tight or anything like that. So right now this is just a real coarse set, and really I just wanted to get everything ready to be put back in. So that's all fixed up, and I've also installed that little braid on the top of the capacitors there. So on the bottom side of the board there's a braid with a little piece of insulating material that goes over the top of those capacitors, and that is also reinstalled. If you find the reference oscillator in your CRF-320 has moved beyond the adjustment range of CT1003, the two other capacitors you can try to adjust will be C1070 and C1069. Now, your results will vary depending on how your receiver has aged, what kind of environment it's been in, how the crystal itself has aged. In my case, I found that adding 3.9 picofarad across C1070, which is a 30 picofarad capacitor, worked quite nicely, and replacing C1069, so removing this capacitor, which was listed factory as a 24 picofarad part, replacing that with a 22 picofarad part. In this picture here, you can see I've used 0402 components and I've soldered them on the rear side of the board. This is a nice clean addition. Both of these components are NP0 rated, and those are the only kind of components you can use in a circuit like this. Now you'll have to also keep in mind that adding that piece of shielding back over top on the circuit will also add a little bit to this circuit, so you'll have to keep that in mind when CT1003 is adjusted to half mesh. You'll find that you'll have to adjust the added capacitance of that shielding out with CT1003. So if you've half meshed CT1003 to start with, you'll find that if it was exactly at 500 kilohertz, you'll find that it'll be just a little bit off center because, again, the added capacitance of that shielding will add a little bit to this circuit here. The synthesizer board is back in, and I'm going to turn on the receiver and measure the 5-volt source here. And if there's 5 volts here, we can pretty comfortably say that all the rest of this is getting that 5 volts. It was 4.8 as we measured it before, to be exact. So I'll focus you on my voltmeter here. I'll turn on the receiver here, and I'll just probe that red wire. And there it is, 4.86 volts. So that's a good start. So we roughly set the oscillator before. I imagine it's running right now, and one way to find out is to turn the receiver around and take a look at that display. And if the display is operating correctly, we can pretty much say that that whole section is working. So that's what I'm going to do now. I'll just turn the radio around and I'll be right back. The radio is turned around. Let's see if the counter has come back to life. You know as much as I do at this point, so let's experience this together. I have the radio plugged into a Variac isolated supply here, so I have to turn it on at the wall. And it's on. 1.152 megahertz. So what I'm going to do is rotate the dial here and make sure that the VFO is working and the counter's working with it. Looks good so far. Looks very, very good. Yep, no problems. So the counter's back to life. It's nice and stable. Of course, this digit will flicker sometimes depending on where you have this sitting. If it's sitting right on the verge of a change, this will flicker. Like that. Right now it's, going from 2 to 3, right? Yep, very stable. So that tells us that the reference oscillator is back to life and everything's working. Very nice. So now what I'm going to do is I'm going to roll it up here. Let's try 1840 is fine. Okay, so what I'm going to do now is hook up a speaker and get a signal generator turned on and everything. And we'll try it out and see if the thing receives. I have an external speaker hooked up to the receiver now, so we can test out the receive section and see whether the receiver's on frequency or not. It's been about, I'd say an hour, maybe a little over an hour since I've been here. I got pulled away from the video here for just a little bit, and the receiver's just remained on the bench here. The display hasn't moved at all. It's still at 1840. I haven't touched this at all. The only thing I did about an hour ago was hook up the external speaker wires to the receiver here. So keep in mind that the synthesizer box is wide open. This is a free running oscillator, this VFO, and this hasn't moved at all. 1840. That is extremely impressive. So Sony definitely did their homework on the capacitors inside this VFO. So what I'm going to do is show you the signal generator here. This is what we're going to put onto the antenna of the receiver here and put a signal into it. So it's at the same frequency as the receiver. It's got a 50 microvolt output signal. That's a nice stout signal to feed into the receiver, and there will be a 1 kilohertz tone on that modulated to 50%. So, before I go about putting this onto the external antenna, I'm just going to clip it onto the pop-up antenna here, just for a really quick test. We want to make sure that some of the controls here are set correctly. So we want to make sure that the RF gain is to the maximum, and we also need to make sure that the pre-selector is in the right spot, or this receiver will be deaf. The pre-selector tunes the front end of the receiver, so if this is off by just a little bit, the receiver really goes deaf. This has a really, really tight peak on this, and you'll see here in just a moment. So the way to find that at first is just turn the volume up, listen to the static level, and tune this very slowly, and you'll hear a slight rise in static, or maybe even dramatic, depending on what particular band you're on. So I'll turn this up, and if this is working, we should get a peak. I heard a click there. it is. I can hear some clicking and popping in there. So it sounds like there's some dirty contacts or something in here, maybe a bad solder joint, so I'll probably have to remove this as well and go into the pre-selector unit and clean it up, make sure everything is good in there, and I'll put this back in here. So, but we have a peak, that's important, so if I bring my fingers close to the antenna, we should hear a really big rise in static. As you can hear, it gets really loud. So if I touch it, it gets very, very loud. So what I'm going to do now is I'm going to clip my signal generator onto the receiver here. So I'll connect the ground to the chassis on the back side. And I'll press the pop-up antenna once here and pull it out just a little bit. And I'll clip my test lead onto the antenna. And now I should hear a tone if this is working. And that's really strong at 50 microvolts. So let's turn that down to, say, 10 microvolts and see what kind of a signal we have. Wow, still strong at 10 microvolts. Let's go down to 1 microvolt. Wow, not bad. Receive section's working very well. So I'll just move this around and see if we're close to being on frequency. Yeah, it's very close. You can hear that it rated 1840 is right where it's at. So we haven't even set the reference oscillator yet. We just kind of pre-did that before we put it into the synthesizer. So everything is working good so far. So of course, now I got to go and set the reference oscillator, and I'll probably remove this here and clean that up or see if there's some loose contacts or something inside that. I'm adjusting the bandpass filter board here in the synthesizer unit, and in order to adjust this you have to remove it out of this box here. So I've got the RF active probe tied in here, and I have my tracking generator tied in here as well. And what I'm doing is I'm adjusting L1008 and L1009, and I'm looking for this pattern right here. So I'm looking for a maximum double humped waveform, and the marker is at 42.645 megahertz. Now, in order to adjust L1008 and L1009, you need to take the slugs in L1007 and L1006 and back them right to the top of the core, or there's interlock between the two and you won't be able to get your adjustment correct. So if you have this adjusted correctly, it's going to look like this on either your spectrum analyzer with a tracking generator, that's what I'm using right now, or if you have a sweep generator, you should get a similar pattern like this. So now that I have that pattern, I have to go to L1006 and L1007, so I got to work my way back to these two now. So I have to tie the tracking generator, which is this cable here, into a different portion of this board. The RF active probe stays at the output, and of course the reason for that RF active probe is to have extremely light coupling into the circuit. Right now there's a 3 picofarad capacitor even tied into the RF active probe, so there's zero loading at all on this circuit, really. Very, very little, if any at all. So that's what I'll do next. I'm going to adjust L1006 and L1007, and I should get the same pattern again. I've now adjusted L1006 and L1007. That required me to move the tracking generator to a different portion of the board, marked B in the alignment procedure. Just tuning for the same waveform here again, with the marker being at 42.645 megahertz, or in my case, that's the center of the screen on my spectrum analyzer. So that's adjusting these two slugs here, which are these two slugs right here. So in order to adjust these, the slugs in these 3 cores have to be back to the top, or there is interlock between these. So the setup is much the same. The RF active probe hasn't changed, it's just the tracking generator input has changed to a different portion of the board. And if it's aligned correctly, you'll end up with a waveform that looks like this. So now what I'm going to do is move on to portion C here and align L1003, 1004, and L1005. I've moved my tracking generator to portion C of the circuit board in the alignment procedure, and I've adjusted L1003, 4, and 5. Those are the 3 slugs in these forms right here in this box. And this is the resulting waveform. Now there is quite a bit of interlock between these 3, so if you're adjusting these 3, you'll have to adjust the first one for a peak, the second one kind of for the center of the screen, and then the third one will start to rise on the left hand side of the screen. And then once you've got kind of a really weird looking waveform, it kind of almost goes down on a slope, you'll come back to the first one here in the box again, and that will even everything right out. Again, there's a lot of interlock between these 3 little coils here. But if it's done correctly, you'll end up with that right there. So now what I need to do is readjust L1003 through L1009 and fine-tune everything to get this waveform here or something very close to it. The final alignment in block C has been done. So basically it's just fine-tuning L1003 through L1009, fine-tuning everything that we've already done to get a waveform that looks like this. Now I've got 2 markers on my screen, one at 42.145 and one at 43.145. So those are the 2 markers there, one there and one there. You can ignore this one over here. So you see that I have a slight rise here and it comes down to the first marker, kind of a dip to the first marker. Alright, so you can see the slight rise and comes down to a dip to the first marker. Alright, you can see the other marker is in a peak, whereas this one is in a dip. So you can see this other one here is in a peak, whereas this one is in a dip. Now the center of this lines up pretty straight, which is kind of nice. So it aligns up a little bit nicer than what's here. They want everything to stay within 3 dB, and everything is well within 3 dB here. So each one of these little lines on the screen here, I don't know if you can see that, is 2 dB. So it's well within 3 dB. So everything worked out very, very well in this alignment. Now, in order to do alignment like this took me about an hour and a half, or maybe even just a little bit more. And there's quite a bit involved. I have the use of an RF active probe that I'm using so that I don't load the circuit, and the tracking generator is tied into, well, it gets tied into 3 separate portions for this alignment, 1 portion at a time. So these parts you see floating here are just what I tie into different parts, kind of just tacked into the way there. So in order to do this, you need, a few markers. I'm using both of these signal generators here as basically marker generators for the spectrum analyzer right now, and those just tie into the input up here. And the output of this tracking generator runs through this black cable and runs to the input here on this board and gets tied into circuit the way that they suggest. So basically a more light loading into the circuit. So if you are in the synthesizer section here and you're working on any of this and you think that none of this has been touched, I strongly suggest that you don't readjust it. Chances are it'll probably be pretty close from the factory. If it has been adjusted or screwdrivered by somebody else, you have a bit of a job ahead of you. This is requires a lot of equipment and quite the procedure to do this correctly. And of course you want something calibrated, a calibrated screen, so you can keep this within a 3 dB margin here. That's very, very important for this bandpass filter to work correctly. I just finished setting the reference oscillator in this Sony to 500 kilohertz. I don't know if you can see in this little adjustment hole here. That capacitor is pretty much sitting perfectly half-ganged at this point. So lots of adjustment room for the future. I also have the bandpass filter all put back in. So I'm pretty much ready to put the cover back on this entire unit and press on at this point. So this is the oscilloscope probe that I use to get the signal up to my frequency counter. So pin 1 of the UPC 1008C here is where you tie in to get that signal up to the counter. And thankfully my counter has memory. And there it is, 500 kilohertz, perfectly. Nice thing about this oscillator here is it's very, very stable as well. So I expect very little movement through temperature change. In order to remove the antenna tuning board, which is this block right here, it really is quite a simple process. You don't need to undo any dial strings or anything like that. So I'll just move this out of the way here and I'll explain the procedure. So this little board here is fastened on the rear of the chassis here, so you just undo these two screws and this thing will just drop out of the way nice and easy. There's a screw on the bottom here that you undo to loosen off this antenna so that you can slide it out of the way. So you just take that screw out and this whole thing will just slide up like this. And you don't need to take it right out, you can just leave it at the top like that. Once you've done that, you'll need to unsolder a capacitor that's tied to ground here on this shielding. That's this little green capacitor right here. Now, somebody had cut the antenna wire here and tacked it back into place. I don't know why they did that. All you have to do is just take off this screw and the whole bracket and everything will just come out the top here. So for some odd reason, somebody figured that cutting the wire and resoldering it would be easier. So this is one of the main reasons that I removed this. I want to make sure that they haven't really tampered with the antenna tuning section, and it looks really good at this point. So once you've undone all of this stuff on the back here, what you've got to do is take these two screws out on the front face. So once you take these two screws out, they screw into this plastic block here on either side of the shaft. Give these little tangs here just a little bit of a push and the thing will pop out, all right? So just to loosen off those retainers just a little bit. Now once those are loose, there's a cable that plugs into a connection over here on that block. And this is the cable right here, so you'll need to pull this cable up or you won't be able to remove this. So you just get a pair of bent nose pliers and gently pull up on that and it'll come out of the connection right at the end. Now to get at that cable, you need to undo the two screws on either side of those two potentiometers. So there's a screw here and a screw here, and that whole bracket system will just come right out. Now once you have that bracket system out, it's a really good time to spray some contact cleaner in those potentiometers before you put it back. And that really is the procedure. So this whole unit looks pretty clean, doesn't look like anybody's really tampered with it in here. I think what they did is they went after this switch and tried to clean this switch. Well, there's a little bit of a catch here, and this will probably catch a lot of people if you don't look at the schematic. If you read DC resistance across this switch, it'll show a short no matter whether the switch is engaged or whether it isn't. There's two coils that are connected across this. So basically what it's doing is it's switching between two coils which have a common ground. So it's going to your DC meter, whether you actuate the switch or whether you don't actuate the switch, it'll just show a dead short in both positions. I figured somebody maybe figured that the switch's action wasn't working. That is a bit of a catch for anybody that's not going to take a look at the schematic there. The next thing on the list is to recap the power supply. So in order to get this power supply out, it really is quite simple. You just undo some screws on this lip here and just unplug this connector, which is basically just pull up on the connector, and the power supply comes out just that easy. So to get inside, all you do is take out the screws on the lid here. All right, and then just pull the cap off and you're inside. So what we're going to be doing is replacing these capacitors here, and in order to get at these caps, I need to undo this screw here and this screw here. Once you've removed this little cover here, it's basically just two screws, and they've put that glue around the perimeter as well. You're in at the circuit board. Now if you want to get the circuit board out, you're going to have to remove the glue around the bottom edge here. I've already done that. And then all you do is just pull straight back on the board, and the whole board just comes out like that. And that's what's in the power supply. Not a whole lot, just a bunch of filter capacitors and some small components here. So the next thing on the list to do is to replace all of these. I'm ready to desolder the capacitors on the board. Make sure you take note of the polarity of the cans. There are no markings on the circuit board. So the negative is pointing this way, the negative's here, here. The negative is on this end here and on this end here. So when you're replacing your capacitors, you want to use some good quality capacitors. You can see how much smaller the new ones are than the old ones. But they do the same job, and most likely with better ESR. So these caps are all ready to come out now. So they have that glue on these things again, so you're going to have to kind of snap them out of the board carefully. Make sure that they're not attached to anything around them. So they've been really nice and they've done this, you know, crusty that is. So there's one of them there. Oh, there is a marking underneath the capacitor, which is nice. So the little end that looks like a C is the negative end. Yep, so that's nice. And I'll remove these two here once I've got these ones soldered back in. Once you have the power supply completely recapped, don't forget to re-glue the thermistor back to this capacitor again. So there is a small thermistor sticking out of the board and it was attached to the old can. Other than that, it's ready to go back together again. The next thing I'm going to do is replace the electrolytic capacitors on this board here and surrounding boards. I'll start with this little one here that's glued to the bottom. Now I've replaced quite a few electrolytic capacitors in this receiver already, and every single one of them tests out okay, and they're not physically leaking or electrically leaking. They're absolutely fine. Really the only reason I'm doing this is just for preventative maintenance. Kind of makes you wonder what's going on today with all of these new capacitors that are coming out that are, you know, failing within a year or two. These things were built in the 70s and they're still working absolutely fine. This board here is the audio board, and you really can't tell that there's any capacitors on it until you remove it. And you can see that there's lots of capacitors on this board that need to get changed. The next issue to tackle is this bad gear on this shaft here. You can see I'm turning this and nothing's happening, whereas I turn this one and the dial is moving. This is really common in these radios. So what I do is I go to my local hobby store and get a gear like this, and then what I do is I bore the center out and I have a new gear for the dial here. So what I'll do is I'll get the dial apart and I'll show you exactly what happens. In order to get these dials off, it's a relatively simple task. All you have to do is just pull these forward. They're just kind of stuck in here on pins. As you can see that there. So you don't want to get them confused because one's kilohertz and one's megahertz. So the kilohertz one is closer to the larger dial. Then you remove this one as well. Now in order to get this one off, you need to remove this dial first. So that pretty much just slides right out like so. Come off very, very easily. No issues whatsoever. And this one comes off the same way. Just kind of rock it back and forth. You're going to, of course, have to reset the dial accuracy later on. And now to get at this gear, all you do is take out these 3 screws right here, and I'll do that, and I'll be right back. I have the 3 screws out now, and this just pretty much comes out just like this. Just that easy. So it's this gear right here is the one that slips. You can see that on there. Somebody has tried to stick a block or something under here to tension it, and of course that just doesn't work. So what I'm going to do is clean this up and put the new gear on here. The new gear is installed on the shaft, and that's a nice permanent fix. It's a metal gear now, so we don't have to worry about this breaking again. So a nice solid permanent fix. So this will go back together now, and here I noticed that somebody had misplaced a washer out of here as well. So there's supposed to be a washer under that other plastic gear that goes here, so that gear had a bit of travel. So I found a very small spring washer that I'm going to put under there, and that'll take up the little bit of room that was left. Somebody had put a whole bunch of washers here. Actually, they'd spaced this whole thing away from the back, I guess, to tighten up that gear when they stuck this little piece of plastic under it. So this all has to be corrected now. This is what the gearing looks like on the AM broadcast portion of this receiver. So this is a little bit different than the FM side. This stays in the receiver. You don't take this out. But this portion here is pretty much identical to what's on the FM side. Now, if you recall correctly, when I was tuning this side, the dial was turning quite nicely, no issues whatsoever. Yet when I removed this for inspection, this gear here just comes off that easy. So definite problems waiting here. So if your section is still working and say there's no splits in your gear, there's a way to resurrect this. It's quite simple. You clean the gear off, you sand the inside just a little bit with some light sandpaper, and you use some brake cleaner. Clean the gear off and the center with some brake cleaner, and do the same here. Clean this off with brake cleaner here. All right, clean that off really well. Put a dab of super glue on here and quickly slide this gear back on like that, and you should be good for a while yet. What destroys this gear is actually this gear right here. Now, if you look at this gear closely, you'll see that there's a spring and there's one gear on top of the other gear. Well, this little top gear is designed to put tension on this gear to get rid of any dead time. So at Sony, what they do is they wind this absolutely tight like this. You can see how that spring is just stretching in there. I can move this over a little bit. You see how that's just stretching? They bring this right back to the stop and then they slide that in. Now what happens is this is putting continual tension on this little plastic gear here, and eventually this little gear just breaks, it splits. So when you remove this gear here, you don't need to run the full spring tension like they've done at Sony. What you can do is you just take the slack out of the spring and advance it one tooth. That's all you need. Or you don't need to wind it completely tight, and this will work absolutely fine, and you'll get a little bit more time out of your gear. You won't have such a large chance of destroying this little gear here. So since I have this apart, what I'm going to do now is make another gear up for this side here. So I have the gear already. What I do is I just bore out the center to the correct diameter here, and then I'll slide this gear on, and this side here will be good for a very long time. The drive gear for the AM broadcast band side, or the medium and long wave band side, has now been replaced. And that's a nice permanent solution right there. Now, unfortunately, this gear here that takes up the dead time on the AM broadcast band side needs to be at full tension in order for the actual capacitor in behind to have full travel. So basically what's happening is the end stop of the variable tuning capacitor behind is in a dead spot of the gear here, and when you slide this gear back in, it would hit that dead spot. So unfortunately, to get that bit of travel, this needs to be at full tension. So one easy way around that is to stretch the spring a little bit, and that's what I've done. So I've stretched the spring just a little bit to take a lot of that tension off, so that way the gears will last quite a bit longer. Of course, nothing is going to happen to this gear now. This gear is the really strong one. Before, this is the gear that would always break. Now this is the one that's not going to break, and of course now the next weakest link would be this little gear that puts the tension on. So by reducing that spring tension quite a bit, will make this last quite a bit longer. Now, a very easy way to actually bring tension onto this thing is just slide this thing in crooked, so that basically you're just going to mesh the teeth of this first metal gear into the one that is putting the tension on. You can see how I'm moving that behind there. Okay. Now it doesn't matter if that main drive gear moves a little bit while you're doing this, because as long as that is at its end stop, you're fine. So once you see how that's coming close to the end stop in there now? Once you get it really close, just push it one more notch, and now it's slid into the back gear. Turn the whole mechanism and pop it into place, and everything is aligned just fine at that point. The next thing on the list to do is unstick the S-meter. This is a really common issue in this model and in the 330K. I don't know whether it's from plastic shrinking or whatever, but they all seem to have this issue. So you can see it's stuck here. If I tap the meter, you can see it moves down just a little bit. This is a relatively easy fix. To get at the rear side of the S-meter, the first thing to be done is we have to remove this bar antenna, and that requires removing these two screws here. Now that the bar or rod antenna has been moved out of the way, we can clearly see the back portion of the S-meter. I'll just zoom on in to what we need to adjust here. So this little brass set screw here is what sets the tension on the movement inside this meter. What you really don't see here is that there's a piece of tape over this little area, and you can poke a jeweler screwdriver through that tape and adjust that little brass set screw inside the meter. So get a jeweler screwdriver that will fit that slot, poke it through the tape and give it an ever so slight turn in the counterclockwise direction, and the movement on the meter should free right up. If you also find that the meter isn't resting in its proper position when the radio is off, you can also move this fork on the bottom by doing the same procedure. All you do is you just poke a screwdriver through the tape and you can move that little fork back and forward. Now, you can't adjust the resting point of the meter unless the radio is sitting in the right angle. Right now I have this radio sitting on the side and I wouldn't be able to do this adjustment. This adjustment has to be made with the radio sitting upright in its normal operating position. Once you're done with adjusting the meter, get another little piece of tape and put it over this area just to keep the dirt out of the meter, and you're done. In order to test the meter for proper movement once you've made your adjustments, first make sure that the SONY is isolated from any external power supply, so it's not hooked up to anything external, no batteries in the SONY whatsoever. Basically, picture your SONY sitting on a rubber mat not attached to anything. On the rear side of the receiver, you'll notice a brown and a white wire that run up to the S meter. Follow those wires back down to the audio amplifier circuit board and unsolder the white wire. You can leave the brown wire attached to the audio amplifier circuit board. Set your function generator to 350 millivolts, peak to peak, sawtooth waveform at 0.25 cycles per second. Connect the common of your function generator to the brown wire that's still attached to the circuit board, and attach the hot lead from your function generator or the signal lead to the white wire that runs up to the S meter. The white wire again being disconnected from that circuit board. The result on the S meter should be like this. The needle on the S meter should gently go up to the top and just tap the end stop and go back down to the bottom again. Once you're sure that there is no sticking in your meter and the movement is moving properly, it's nice and fluid, you can remove your function generator and resolder that white wire to the audio amplifier circuit board, and the test procedure is complete. The next thing on the list is replacing the incandescent bulbs in this receiver. So there's a bulb behind this dial, this dial, this dial. There's one behind this tape that lights the clock up, and there's also one in the back side of the S meter. All the bulbs in this receiver have green boots over them in order to keep the lighting of the receiver green, aside from the red LED display on the top here. Now, whenever you put an incandescent bulb inside of a green boot, it really does knock the light down quite a bit. And these dials, they don't light up very well in broad daylight or even in a well-lit room. They're kind of, just noticeable. So we're going to go after that and make that quite a bit nicer. We're going to really make this receiver stand out. It's such a nice looking receiver. Why not have really nice, well-lit dials? So from the factory, again, they're using incandescent bulbs because really that's what they had back in the day. And these incandescent bulbs in this receiver, they all do look to be original. They all have that original factory glue on them. So one of the reasons that these bulbs are probably all still working is SONY was intelligent when they did this. They ran the bulbs a little bit below their rated voltage, and they're also running them on AC. Now, whenever you run an incandescent bulb on AC, you avoid a thing called filament notching. So, pretty intelligent by the guys at SONY. Another thing that they've done is when the radio is actually run on batteries, the lights on the face don't light up at all. All right, aside from this display, you actually have to push a button down here in order to light all the lights up, so they remain off. And the reason that they've done that is because, filament light bulbs are current hogs, and that would really put a lot of time on the batteries alone. So they were doing their homework when they were thinking about things. There's a lot of little things in here that I've noticed when going through this receiver that, they really did spend a lot of time in the design of this receiver. There is really quite a bit of thought here. So I'll give you an example of how this receiver lights up with its factory lighting. I'll just turn on the receiver right now. So you can see the clock is lit up here. You can see the S meter is a bit of light, and I don't know if you can see this dial here is lit up just a little bit. All right, so I'll switch to this dial here. This one is now lit up. And I'll switch to this one here, and this one is now lit up. Now to the camera, it's quite a bit more sensitive to this green color than, in real life here. In real life, in looking at this dial, it's barely perceivable. I can see the green on the top here in the teeth. But when I go down to this dial here, I really have to look in behind to almost see that it's on. So the camera is a little bit more sensitive to the green color. But again, very dimly lit. If this was in a very well lit room, the dials wouldn't even be perceivable. I think the clock is about the brightest there is. and even that isn't very bright. So the whole idea, again, is to accent this. So what I've done is I've designed a circuit board that is going to sit on the rear side of this receiver. I'll just shut the receiver off here. It's going to sit on the rear side of the receiver, and it's going to mount into this area right here. So there's nothing factory mounted to this. It's just a square punched hole and the two little punched round holes on each side of it. What that's there for, I really don't know at this time. There's obviously some form of an option that wasn't in this receiver. I've noticed in the 330Ks as well, there is nothing that sits in this hole. So maybe it was, I know that these things had a digital clock option. Maybe it was something that mounted to the digital clock. I'm really not quite sure. But at any rate, it's going to mount to this particular portion of the receiver on the rear side with some standoffs. So what I'll do is I'll show you on the rear side how I'm going to fit this little circuit board in, and we'll go from there. We're looking at the back of the Sony. The Sony's also laying on its side. Right here is where I'm going to mount the standoffs that's going to hold the new LED circuit board. So the LED circuit board will be mounted directly behind the S meter here. You can see the factory lamp is still glued in place with that Sony glue and with that little rubber shim here. This will all get removed. When I designed that circuit board, I designed the traces for the meter light to end directly behind this hole that's going to be left when this is removed. So when I solder the new LED to this new circuit board, when I put the circuit board in, the LED will poke directly into the S meter. That worked out really quite nicely. You can see here, this is where all the factory connections are for the existing meter lamps. This will all go missing and this rat's nest will get cleaned up in here. My new circuit board ties directly into these traces and sits just a little bit in from it, and the wires will go directly into the circuit board. It really cleans things up quite nicely in here. So when I have that circuit board all designed and put together, I'll show you exactly how it's wired up. The new LED circuit board is now installed, and you can see it's cleaned this area up here quite a bit. There's no more rat's nest of wiring. When I designed this new circuit board here, I designed the traces to be directly in line with the traces on the audio amplifier circuit board. So really, now there's just nice, clean, straight connections, really just jumpers. The circuit board itself is fastened to the front side of the radio with some standoffs with these screws. The meter LED is connected directly to the circuit board and goes right into the back side of the meter housing, right from the circuit board here. These connections here where it says FM, AM, dial, and clock are all wires that run off to the LEDs. The LEDs that I'm using are high brightness green wide angle style LEDs, and they fit quite nicely into these existing rubber grommets. So there's a green LED here, 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 and there's one also in the clock on the front side of the receiver. The new LED circuit board on the rear side of the receiver is fastened at this point right here with these standoffs and these screws. The wires that are coming through the center here go to the LED in the bottom side of the clock. This is the way the new LED lighting system looks in the Sony receiver. I've had to adjust the exposure in my camera just because the green is so bright in the dials here that it causes some distortion in the camera. If the video doesn't really reflect what this receiver looks like, I'll just edit in some still photos. So the dial you see lit right now is the FM broadcast dial. So I'll switch to the long wave and medium wave bands here. You can see how nice and even that's lit. What a bright, vibrant green that is now. The S meter I lit with a white LED just to enhance the way the meter really looks. The way that Sony did that from the factory is they installed a green boot behind there, and that green boot really just drowns out all the whites in the meter. So this really makes that meter just stand right out. So we'll take a look at the short wave band here. You can see how well lit that is now. So all in all, this LED addition to this receiver just absolutely makes a world of difference in just the way that this thing looks. So nice and vibrant and green. It really does show off the receiver quite a bit. Even the clock is much, much brighter now. Here's one extra little bit of information that isn't in the Sony service manual. In fact, they tell you if there's any problems with the VFO block just to completely replace it. Well, of course, there's no components available for this thing right now, so if there's anything wrong with the VFO block, you're going to have to fix it and do the best you can to make the dial track correctly. So if your dial is tracking correctly, this takes a long time to set this up if it's been tampered with. But you can see how it says 3 megahertz and it's right on the 0. So the 0 is aligned with the 0. So if I go to 100, we want it to align with 100. If I go to say 500, we want it to align at 500, right on the nose there. You see here at 700, right? And then 900 again. All right. Right there. 900. Okay, and then we have right at the end of the dial, and it should come in about 99 right there. And then at 1,000, it should just go back to decimal places. Now, when Sony designed this VFO, an incredible amount of time went into making this VFO do that. Making a digital display is pretty simple because it just really looks at whatever the VFO is putting out. But making a completely even dial scale, an analog dial scale, track with a digital counter on this particular scale here is an incredibly difficult feat whenever you're designing a VFO. So Sony did spend a lot of time in this area, and that's the reason they tell you if there's a problem with that VFO block not to service it and just replace it. Now, everything in that VFO block would be hand-picked and everything would be graded before they put it in there, and that's the reason they don't want you to service it. If you had to change a FET or a transistor or something, or even a capacitor inside there, the chances of getting this to track correctly again, is going to be very difficult, put it that way. So if somebody has tampered with the tracking on this, the only way to readjust the tracking is to move this plastic piece in behind here around, all right, the dial scale, to move that around in there. And on the rear side of the Sony, there is an adjustment that you'll have to work in conjunction with setting this plastic scale in order to make it track correctly. Now, when I say track correctly, it might read 950 here, all right, but if you go down to, say, 500, all right, 500 might sit there. And then if you go down to, say, 100, 100 might sit here. And that's what the tracking is. So the tracking keeps it right on the actual little indicator right there, right above the number. So that, again, is an incredibly difficult thing. So if somebody has played with this, there's going to be quite a bit of time put into this alone. And yes, somebody played with this one and it was way off. It was up here somewhere. So quite a bit of time just in making this track correctly again was, put into this. Now I'll show you on the rear side of the receiver where the tracking adjustment is on the actual VFO. On the VFO itself, this is the VFO block here. This hole here that doesn't have wax in it, this has got wax in it, you don't want to tamper with that at all. This hole here, there's a variable capacitor set way down inside here. And you'll have to work with this variable capacitor and that plastic dial scale on the face in order to make the numbers line up to the digital display. Again, if yours is very close, I strongly suggest not tampering with it. If it's way off, or you've replaced a gear or done something like that, you have a little bit of fun ahead of you. And let the fun begin. So during the test procedure, when this was all done, I noticed that very, very randomly. So basically you could move the dial around on the side here. You can see this is the side I'm on right now under the digital display. So very, very randomly, you're just moving the dial around, and then all of a sudden it would get kind of stiff in one spot. And so you back off on the dial just a little bit and it would be free again. And there's no time or amount of turns or anything that would make this problem reoccur. It was absolutely random. So to give you an example, I could move this around for an hour and it'd be fine. And then, an hour and 1 minute, all of a sudden it's doing it again. So that made the issue very difficult to find. And I imagine that's why the person before me had been in here and had, tried to adjust this. And they did a whole bunch of odd things. They added washers in behind, there's another plate that goes here that holds the gears in, and they added some washers behind the main dial and did some things. I guess they figured maybe the dial was jamming, maybe on this extruded piece of plastic here or something like that. This extruded piece of plastic here is where the dial lamp is put in from the rear side, and it lights this little area up in here that lights the dial up. So not wanting to take this whole thing apart and take all the gearing out of here, it's quite a procedure. You got to take this all out, you got to remove all these gears, and you got to put them all back in and put tension on them again. And And there's this little shaft that sits right in here. That's the main shaft that sits in here. So after a lot of fooling around, I ended up finding the issue, and it's a very odd issue. There's a little piece of plastic on the back side of this. This is a gear, and then it's a metal collar here, or a brass collar. And what they're using this little piece of plastic for is an end stop at the dial, so that you really can't take the variable capacitor here that's in the box. All right, this is the VFO variable capacitor, so that you can't bottom it out. You can't bring it right to the end. So this here is just an end stop. And what was happening is there's a crack in this piece of plastic right here. And what would happen is this little tooth here, because it's just freewheels, this little thing just turns around and catches it once every revolution. All right, and it kind of moves it one step, one step, one step. Now, since this thing is free and it can move around, this little tooth can drag on this little plastic collar sometimes. And what would happen is that tooth would get caught in that little crack there, and it would jam up. So you'd back up again, and then move it again, and when you backed up, it was just enough to maybe move this a little bit, and then it would run free again for a bunch of time. So it really was quite a bizarre issue. So I had to fix this piece of plastic, and that really is quite a challenge within itself. So what I'm going to do is I'll get the camera a little closer here, and I'll show you the action of this little piece here, and I'll tell you exactly how I fixed this. So I've noticed with one other SONY CRF-330K way in the past, it had a very, very sporadic dial. Now, it wasn't this part, it was the actual gear on the backside of the dial had a crack in it. And I was thinking that that's what this is. You can see here, this is this big gear here, that had a big gap in it. And of course, at that point, you know, you're dealing with trying to either get a new gear, or you're going to try and manufacture something that's going to fit in the missing area. It's like this plastic shrinks or something. It's really bizarre. But this is in very good condition, and I was very happy to see that. I was thinking, oh no, you know, this has got a crack in it. Here we go. But this is almost like brand new. So it's looking very, very nice, the gearing here. So it turned out to be this little stop. So again, I'll just move the camera a little bit closer, and I'll show you exactly how the action of this is working. This is how that dial end stop works in this Sony receiver. So I'll just insert this in any old portion of the gear here just for demonstration's sake. So see this little filed line here and that little gray line down there? That's where the crack was, and I'll explain that here in just a little bit. So you can see as this is rotating around, you see that gap in the plastic collar there? It catches a tooth on this gear right here every time you go one revolution. All right, so it catches it, moves it one more area, catches it, moves one more area, and right now we're going to come to the stop. There's another little piece of plastic that's just up against the brass collar here, and it hits the stop. So technically, this is at the end of its area then. So you can see how this tuning capacitor has an end stop on it. It goes, you can hear that, it's at its end stop. Well, what's happening is that they're stopping this capacitor just before it bottoms out on its own end stop. Now, the reason they may have done that is because there's quite a bit of gear reduction in here when you're spinning the dial, and they figure maybe that you could damage the capacitor or decalibrate the VFO by putting too much force on it. So they're using this external plastic stop. So as this is turning the other direction, you can see it catches it, you know, one tooth every revolution. And now, of course, this is going to be spinning in the opposite direction as you're doing that, right? So you're going to come to this end here. All right, and then it's going to hit this and stop here. And now this would be at the other end, but it's going to be stopped just before this hits its end stop. So what was happening here, all right, is where that crack was in this little piece of plastic here. You see the little gray crack there. And you'll notice that on this piece of plastic gear, there's two extruded pieces here. There's an extruded piece here, and there's another one up here. Now, at the top end of the dial, if you move this around, those pieces are adding weight to this end of the dial. So this piece of plastic, the gear wants to fall now. So what's happening is that tooth right there is now going to start to ride that nylon or that plastic collar on the end stop. And you can see where that crack is? Well, that tooth will get stuck in that crack. And since this is cracked, what would happen is when it's stuck, that piece of plastic end stop would spin on this brass collar here, and it would pose some resistance, but you could still move it. It didn't decalibrate the dial or anything. It's just that you could bring this right to its end stop. And then of course, if you back this up just a little bit, it would make it free and it would work again for a while. Because you can see when I'll just move this, you know, just kind of randomly. Okay, so now you can see I've moved it randomly. I'll grab this. You can see how that it'll just free float. All right, so it's not really that tooth there, or any of these teeth aren't always necessarily riding that nylon collar. A lot of the times it would sit just right in the center. All right, so as you go around, as you say you let it sit for a half an hour or something like that, there's a little bit of a you know, some grease behind here, so that acts as a cushion on this gear. But you let it sit for a half an hour, and this slowly settles down and rests on this piece of plastic here, on that little nylon collar, and then again you come around and then boom, it would catch in that little crack. So you got to fix that little crack so that it's nice and smooth, so that it'll go right across it like this with no problems. And the way to do that is you got to take this piece of plastic off. It's cracked. It'll usually come off pretty easy, so you can get an X-Acto knife or something and stick a knife in there and then slowly edge this piece of plastic off. The brass that's under here is knurled, so you can see there's a brass under here, and this piece of plastic fits on this brass collar. So this has shrunk, and that's the reason that it's cracked. Now, the reason that it shrunk, I have a pretty good idea that they may have used just regular grease, and that causes problems with plastic over the years. So when you re-grease this whole system, you need to use a silicone-based grease, or you're going to start to have problems in the future again. So it's very important. Do not put regular grease in here. So once you have this piece of plastic off, you file down the knurling on this brass shaft here just a little bit, so that there's not so much of a gap here, and you want it to kind of close a little bit, but you still want a gap so that you can get your epoxy up through there. Now, I use a product called JB Quick. It works very, very well. Before you go about fixing this, you want to degrease this. You need to use brake cleaner and a toothbrush. So you hose it down with brake cleaner, brush it with a toothbrush, hose it again, brush it again, hose it again. This needs to be bone dry, not a drop of grease or oil on this or this piece of plastic as well. So of course, when you're hosing this down, this piece of plastic is off. So you hose the piece of plastic down, get that brake cleaner within the crack. You might have to part the crack just a little bit and spray it in there, and brush in there and spray it, and use Q-tips and clean this thing till it's like this thing is just is blazing clean, no grease whatsoever. This entire shaft is completely degreased, and your fingers are clean as well. Mix up some JB Quick, put some JB Quick on the shaft, on that newly cleaned up, filed, knurled shaft. Again, you want to take some of the knurling off so that there's not so much stress on this broken plastic collar. The last thing you want to do is put a crack on this side, and that's a big problem. You can see there's a small one here, and there's also some JB Quick pressed into that as well from the inside of the collar. So you got to make sure, if that crack goes all the way through and this thing parts, it's very, very hard to make this thing, sit on that shaft again. You'd have to, clamp it down and hold it tight on the shaft and fill everything with JB weld and let it sit. And, that makes things quite a bit more difficult. So if it hasn't cracked on both sides, make sure that you don't crack it. So what you do after you've got everything cleaned off and, you file that, smear JB weld all over this brass collar here in the center, and when you have this piece of plastic off, you want to put JB weld in the center of the bore of this, and you also want to push it up through the crack. So you want to make sure that there's a decent crack. You don't want to fully close this crack, and that's for good reason. You want to have it a bit of a gap there, and you want that JB weld to come up through. All right, so when you're putting JB weld in the bore of this piece of plastic here, you want to take a screwdriver, a rounded screwdriver, and press it up so that it comes out of this. Make sure there are no bubbles or anything like that. Make sure it comes up nice and true. Slide this piece of plastic back on the shaft here again. Now you have to make sure you mark this brass collar in an area with the crack so that you can see how there's an Allen screw here. All right, you want to make sure that Allen screw is at 3 o'clock, because when you're putting this back and you're aligning everything, these two are going to be loose. All right, and this one is the only one that you're going to tighten. So when this thing comes to its end stop like this, you can't rotate this thing anymore. It's at its end stop. All right, actually the end stop is going to be, if I put this here, the end stop would be right there. Okay, now you need to have an Allen screw right here so you can get an Allen wrench in from this side. You can't get in from the top or from any other area here. So it's very important to do. You can see how that one is sitting at 3 o'clock right there. Okay, that's very important to do. So there's a bit of sizing before you put this thing back together. I filed this before I did all this in line with the crack and lined everything up, because once you got the JB weld on here, you have to work very quickly. All right, you don't want to use the slow curing JB Weld because it'll run out of the crack. You want the stuff that's quite a bit thicker. The JB Quick works very, very well for this, and it sticks to this quite well, you know, very, very well. The reason that you want a bit of a crack in here is because basically there, you can picture that as a card of JB Weld running right down to the center of the shaft. If you make this too thin or you glue it completely together again, there's a chance it's going to separate. Since you've filed the knurling off that shaft, now it's trying to close, all right? There's a lot of tension on it, and that JB Weld gently fixes the crack. Now, when you're letting this cure, you need to clean this off really well, but you need to leave a little bit of JB Weld over the top of this nylon surface and down on the other level as well there. Once it's completely cured, you need to file it true with the plastic or nylon gear here. You need to file it completely true so that it's nice and soft, so that there's no ridge whatsoever. All right. Now, when you've got rid of that ridge and everything's fine, you're going to put a new coating of silicone grease on this, and it will be just absolutely smooth at that point. You'll have no problems with this. You know, the gear will, you know, when it comes around here, you know, and it has to ride on that piece of, you know, in that area that's been re-glued, it's not going to catch on there at all. It's just going to come around nice and freely. All right. So again, the JB Weld has to be very true to the top of this piece of plastic or nylon on both levels, because there's another little bit of gearing down on the bottom here. All right. So that's how you repair this. All right. If yours is completely split off, then you're going to have to, you know, again, put a JB Weld on here and clamp it tight. You want to get rid of some of the knurling in there so that it will close a little bit nicer. Again, this gap was quite a bit larger before I started. All right, so that takes a lot of stress off of this shrunken piece of plastic here. Now this has been completely cleaned off, and again, I'm going to use silicone grease in here, and you need to do exactly the same thing. You don't want to use any regular kind of grease in here, because it does decay these gears and causes shrinkage and all sorts of problems like that. So once this is all fixed, you have a lot of fun, you know, timing everything and putting it back together, and I'll briefly go through that and give you some hints on how to get this to stop, you know, just a little bit before the end stop here and a little bit before the end stop here. And that does take a little bit of time, and it is a little bit of tedium, shall we say, but that'll be the next step. The first step in the reassembly procedure is, what you want to do is loosen off all three of these hex or Allen screws. All right, so you want to loosen all of them off, so that what's going to happen is this is going to freely spin on this brass collar. You can even remove it if you want. You see that? So what you're going to do then is, once you've got all three of these loose, what you're going to do is you're going to just put tension on the one that you've marked that's going to sit at 3 o'clock here. So just put a bit of tension on it. So just snug it so that it'll slip on the shaft, but you can feel the resistance. Once you've got that done, what you're going to do is just insert this in any old place in the gear. So just insert this so that it catches the teeth correctly. All right. Of course, with a liberal amount of silicone grease on right now. So that's the second step. All right. And then what we're going to do now is take this gear here, and we're going to reinsert this gear. So you'll notice that in these gears here, they have a bunch of holes. There's a hole here and a hole here, and a piece of number 10 wire will fit in there pretty good. So what you need to do is hold one side of the gear. All right, you need to figure out which way it goes. This top piece here is part of the shaft, and the back one is the one that moves, that puts the tension on. So you have to move that rear piece over, and you can see how there's a little hole coming into alignment here. You have to hold this gear, open that hole up. All right, so you've got it right about there. Put a piece of number 10 wire in there, usually from the back side, just a little piece, and that will hold that. Now make sure you don't lose that piece of wire into the radio when you're pulling it out. So anyways, put a piece in here, and that'll just hold that nice and tight, because this is what's putting that that pressure on the gear to stop the dead time. All right, so you can see that when I let it go, how that other gear moves behind this. So that's what that does. All right, so that's the next step, and you're going to also have to do that with this gear right here. This gear does much the same thing. All right, you can see here, you see these little holes here. See, I'm rotating it, how the holes come into alignment there. You have to put something in here to hold that, all right, because it's going to want to spring back. Same thing here again. Number 10 wire fits pretty good. It's a little bit slack in there. You might need to take the piece of number 10 wire and squish it a bit just to hold that open perfectly. But a piece of number 10 copper works good. Again, don't drop it in the radio when you're pulling them out. Alright, so in order to install these gears here, again, they both have to be done at the same time because this one, the teeth mesh into this gear here, and then the teeth on the back side of this gear mesh into this gear here. Now, if you're really good and you know the skin on your fingers isn't too sensitive, you can actually hold these, you know, move the two gears until the holes align, and then push this in like this, and you can do it without those pieces of wire. If you're not too worried about, you can see on my fingers here, it kind of grabs your finger a little bit when you're doing it. But that's how I did this. Easier way, of course, you know, putting pieces of wire in, but this is really quick, so I just held them and then snapped it in. Works very well. So this is in here now. So the next thing we got to do is put this plate back on. You'll know that when the gears are actually aligned correctly, that the holes usually don't move all that much. They're usually pretty straight in line. If one of the holes is, you know, it looks like a half moon or something like that, chances are it's one tooth out. It doesn't really matter. It just puts a little bit less tension on this gear. But since these gears are metal, it's absolutely fine. You know, they're not going to strip or anything. These have been in here since, you know, this radio, and they're in great condition right now. So once you've done this, again, a liberal coating of silicone grease on everything in here, even these gears, because you don't want it to in any way, shape, or form to get on the plastic. So just, you know, be safe and use silicone grease everywhere, and you can lubricate everything up like that. So again, the next step here, you can see the old grease they've used doesn't look like silicone grease, right? Silicone grease is usually clear or a white color. So after that, this has got to go on. This goes on like so. So it fits on here, and this little gear is over in this area. So I'll put this on and put the screws in, and we're ready for the next step. These don't have to be in any position. They don't have to be in because there's no actual, you know, breaks in the gearing surface. So these will just keep rotating no matter what. So you can just pop these gears in any old position. All right. The only thing that's going to cause any issues is this collar here, because it's going to want to lock at one end of the dial, and that's the reason that we've put just a little bit of tension on this little hex screw in here. Once you've got all the gearing put back in, and again you have just a little bit of tension on this rear gear, hardly any at all. In fact, you might even find that it depending on how much resistance there is, because sometimes when they've put the little hex screws into the brass collar and tighten them against the shaft, sometimes it mars the shaft just a little bit, so sometimes that might even be just enough tension. So once you've figured out your comfortable area there, you can feel that mine has a bit of tension on it, not much at all. That's that little brass collar that we just repaired with a little plastic end stop on it. Okay, so once you've got all this done, what you want to do now is turn on the radio. All right, and you want to make sure that there's travel from end to end. Okay, so you want to go all the way down here, make sure nothing's going to bind. You're going to go all the way down to the bottom here, and you can see that. See, I'm still using the capacitor end stop at the bottom here because this piece of plastic isn't working at this time. That little collar's just slipping in there. It's turning on the shaft, and it's advancing it one tooth at a time. So the travel is good. It comes right to the end. So once you notice this at the end, what you want to do is you want to take that little brass collar with your finger, and you can see that. You see how I'm advancing this? You want to bring this just to the end so that it's stopping at the end here. And then what you can do is you can back this up just a little bit. You can see where it comes to here. And you can give it just a bit of tightness, all right? So make sure that this is at its end. Right now it's at its end, so give it just cinch it up a little bit. So technically, this is stopping the capacitor here from hitting its end stop now. Now this is going to be in use. So what I'll do is I'll get in there and I'll just tighten that up with that Allen key. Now you don't want to tighten it up very tight, just snug it again, all right? So if you find that yours is you know, a little bit hard to move on the shaft, that little brass collar is hard to move, you might not even need to tighten them up. Again, just depending on how badly scored the shaft is underneath that collar. So if it poses enough resistance so that you can tune the dial, and this little piece of plastic here is still going to, you know, move with this dial here, you're pretty much set to go. So the next step is putting the dial in roughly and sizing out each side of the stop, and I'll explain that here in just a second. The next thing to do is to put this gear back on right here and tighten up the 3 set screws. So again, it's not really too important where the position of this gear is sitting right now, but just put it on and tighten these up. Again, you don't have to wrench them tight in the beginning, but you know, tighten them up fairly tight so that this doesn't move at all on the shaft. Now that the Allen screws are tight on this bottom gear here, so this is tight on the little shaft here, You'll notice that there's another spring in here, and this is a stacked gear, again, to take that dead time away. You don't need to worry about that. Just leave this in its resting position right now. It's not so important to set this. In the end, when you put it all back together permanently, you're going to want to put that tension on the gear that sits in the center, which is the main dial. All right, so once that's done, you see this is the main dial here, and this is two separate gears as well. So what happens is you can see that this is pretty much dead center right now. You know, I can set this to dead center right there, but you'll notice at the bottom of the dial, it's completely out of time. Well, they have a staggered gear rate here that moves these two gears, which is these two dials here, a little bit at a different time, one from the other, okay? So for now, it's most important to keep this line here in alignment with this line here. Now I put a little black felt line here. From the factory, they've punched this. You'll see a little punch mark in here. It's right below this 7-segment display. When you put this in, what you want to do is leave this center collar. There's a center collar that goes in here, which is this piece. You just leave that out for the beginning, all right? You also want to make sure that this brass collar slips on the dial here. So basically, they've glued this, and you want to make sure that this will slip in the center. So you have to break the glue here. All right, that's very important. So make sure that that glue is broken. Sometimes it's easier to do that with it actually in the receiver and all the gears are kind of holding everything steady. And I'll show you that here in just a moment. So when you free the glue, make sure you don't crack any of the plastic. This plastic is very brittle by now. All right. So what you want to do is take this, and you can sit this on top of this gear. This is pretty much at the end of the dial right now. So what you're going to do is take this, put this in like so, and just rest it in the top of the gear with this as close to being centered as possible right now, all right? So when you have this centered, you take this little brass collar. It has two holes, large holes. One of the holes is right at 6 o'clock here, okay? So you put that onto the shaft there and just slip that in like so, and then you can let it go, it'll fall forward a bit, and then put one screw in there, and after that, we're ready to kind of pre-align it at this point. Once you have that screw in, holding the brass collar here, you should be at the bottom end stop, and it's pointing at 0, wherever your end stop is sitting at this point. All right, turn on the receiver. You can see I'm just at decimals now, so when I come here, it's about 4 bars up, I hit the zeros. So now, since we've broken the glue on this plastic dowel to the brass centerpiece here, we can now slide the plastic dowel freely on that piece of brass. So you hold the center shaft with it at zeros, or as close as you can hold it, slide that plastic, all right, and align it up to the 0 mark so that this line is in line with this, as close as you can get. All right, so that's pretty close. Just about right on right there. Okay, so now once that is set, the plastic end stop should stop 3 of these larger bars below the 0. So when you go down here, you see you got this large bar right at 0, you got 1, 2, and 3. The end stop of the plastic should be right around here. Now don't get too particular if it's a bar, a small bar, 2 each way or something like that, not a big deal. All right. The actual end stop of the capacitor itself is down around the next digit down, which would be the 1000 mark again. So if this could keep going to the capacitor end stop, it would stop here, but the plastic is stopping it here. Now, when you go to the top of the dial, it'll be exactly the same. If you've done that correctly, it should be right around the 4th mark above. You can see that the tracking is good on this. Right at 1000, it goes to the decimals again. Okay, so when we come to the 4th bar here again, it's at the stop, and that's at the plastic stop. The capacitor stop would be still over at about the 0 here, if I could keep going. So that's the alignment point there. You want to go 3 of these larger bars beyond the last and 3 below the 0. Now I did that off camera because it takes a lot of time to set up. I noticed that even with that Allen screw on that little brass collar with the stop, it would slip a little bit, but since the shaft was scored, because, from the fella or whoever did this before me pre-tightening those Allen screws or tightening them onto the shaft, put some scoring in, and the Allen screws would catch in that scoring, and I don't want to bust that little plastic piece again. So I did this the slow way. I took it out and, saw how far it would go if it only went to here. I'd take the dial off, of course shut the radio off, take the dial off, hold the shaft, right at its end stop, put the Allen screw in, loosen it a bit, turn the dial, tighten it up, put everything back together and try again. If it didn't work, I just repeat that process over and over again until I got this. So there's a little bit of time involved there, but it works out pretty good in the end if you just spend the time with it. So that's what's involved. So now that all of this is done, I have to remove this dial again, and I'm going to have to put tension on that rear gear in the back. So basically you need to create a hook in order to do that, and I'll just remove this and I'll show you exactly how to do that. The next thing you're going to do is bring the dial to the upper end, so past 1000, to the stop. Alright, so you should be at the stop about that third larger bar over. Alright, in line with this black mark up here. When you've done that, you're going to take this out. At this point, this all really isn't all that important as long as you're up at the stop. Take this off like so. Take that center piece out. Just let it fall into your hand there. Put that somewhere safe. Once you've done that, get in behind here and tighten up those Allen screws on the stop, on that little brass ring back there. So get that done first. Once that's done, what you want to do is check this gear here. You'll see two blind holes. If the blind holes aren't at 11 o'clock and 5 o'clock, just undo the three little screws, just loosen them off and give it a bit of a turn until they are. So this, again, really isn't all that particular. The only reason that we want these holes in this position is just so that we can put tension on it. And I'll explain that here in just a minute. So again, one at 11, one at 5. And since we're at the upper end of the dial, this is at its stop here, okay? This front portion of the gear is a gear that slips on the other one. This is the one that creates the tension. So you'll see there's a spring in here. If I pull this gear forward like this, you can see we're roughly at 6 o'clock now, all right, and it's no longer a blind hole. The hole goes through two gears, all right, and that's the whole idea here. So what you want to do is make up a quick tool, get a piece of number 10 solid copper like this, and make a little tool just like this, okay? You can see how it has a hook. So what I'm going to do is I'm going to put my finger on here and align those holes, okay? And I'm just going to stick this in from behind. Now when you make this tool, you want it to be as shallow as you can possibly get it, because you're going to have to pop this out of the hole straight once you're done. So you just leave this in here. You can see how it kind of comes off to the side. The reason it comes off to the side is so that it doesn't interfere with the dial that we're going to put back on. Now what we're going to do is take this dial, all right, and we're going to align the 0 mark. Okay, so it says 0 here. We're going to align that with this mark up here, the 0 in the dead center, and we're going to put this thing on and put this down into those teeth. Okay, so we'll put this in here, making sure that this is going to mesh properly with the gear. So what we're going to do is get that close. Now even if this is off, as long as it's pointing really close to 12 o'clock, okay, and that 0 is right in the center. Alright, so once you've got that done, take the little brass centerpiece and push that in. Okay, and then once you've done that, what you want to do is put that screw back in there again. So you're going to put your screw back on the screwdriver here, hold this steady, and very carefully put this back in. Now that this is all in, you can take your tool, take that out like so, and now there's tension on that rear gear. Now what we're going to do is turn the receiver on, okay, and we're going to back this down to the 0 mark. Okay, so we'll start about here, and we're just going to take this, make it bring this right to the zeros, okay, and slide this back over again until it's at the 0 mark, just like that, and you're done. The dial's back in. So now you can put in that other screw there and tighten everything up, and everything will align just perfectly. The 550's right in the dead center of the hole there, and you can see that right at 550 we're right in perfect line with that line. And that's how you repair that problem. Here's a quick example of the FM sound quality on this SONY CRF-320. This is a communications receiver, so I picked a frequency with somebody talking, so let's just take a listen.
Stand up, I walk upstairs, I make my way to the bedroom, and as soon as I walk through the door, I draw a blank. I have forgotten why I am there. It turns out that, yes, it's a thing.
So you can hear how clear that is. Right now the FM broadcast band is really full of action right now. Lots of music and everything everywhere, and all of it sounds just this good. I have the telescopic antenna only pulled out to maybe 2 feet or so, and this is the receiver right now. We can see it's well over S9. Let's take a quick listen to the AM broadcast band. So there's lots of frequencies coming in right now, so this will give you an idea of how well this thing listens.
To me to imagine all intelligence.
Lanes have been real.
About making contact against the string. I started Jones Land.
Massey Tunnel North. Canceling each other out right now. And I'm like, well, that dude sounds career and do something.
7.5 points.
More professional.
Pretty good, and really love me, Gene.
Invoice to go.
And that scene, we've seen both now.
About this industry. This is fresh, and the spur.
Served by stormwater infrastructure. 2 or 3 days ago.
So you can see the receiver works very, very well, and it receives quite strong all the way through the entire AM broadcast band. Let's take a listen to the long wave band on this receiver. That's the bottom portion of the dial here in the low kilohertz. You can hear a weak navigation beacon in there. And a nice strong one here. It'll just do that over and over and over again. There's another beacon there. Lots of beacon activity down in here. Narrow things up just a little bit. Lots of computer generated noises here. You can hear how clear and concise that gets with this on the narrow position here. Nice and clear. Nice thing about the filtering in this receiver. I think that's it for the beacons in this band. So that's a quick example of the long wave portion. Pretty much that's all that's down there now is really just beacons. Let's listen to some short wave. So the upper portion of the 5 megahertz area has some action on it right now. So the first thing to do when you're listening to short wave on one of these receivers is turn the volume up so you can hear static, and then peak the antenna tuning for maximum static. So it gives you a rough idea of where you need to be peaking this. So we see we're at 5.7 megahertz, so we know that we're somewhere between 5 and 7. So there's a little mark here. You can see I've passed it, so now I need to go back the other way again. Once you've found maximum static, you're ready to start looking for frequencies. Really what this is doing is this is tuning the front end of the receiver to the antenna. So I'll just start searching the band here.
Glenn Beck.
earth the glory of Israel, and has not remembered his footstool. And the day was ended. The Lord is swallowed up. He has not spared.
This guy's got a great broadcasting voice.
In his wrath, he has thrown down the strongholds of the daughter of Judah. He has brought them down to the ground. He has profaned
Wow.
the kingdom.
Jason of the Luciferian worldwide.
Literally, just that.
So that's it for the upper portion of the 5 megahertz area right now. I'll just look around on this receiver to find some more action on another band, and I'll be right back. Here are some guys on lower sideband of 3745 in the 80 meter band.
And tune an antenna like they tell you in the manual. I mean, I know that sounds crazy, but you've used the tuner many times, but
So I'll move it around a bit.
Just go. Recording for your hour. Yeah, 'cause those T-tuners, got the SWR down as low as you can go, and it's not really the right place. They're very easy to get confused with that, especially on some antennas. So, good idea. Get a good night's rest and get it straightened out. So, anyway, 46 degrees up here. It's going to be cloudy all day long today. I don't know if we're going to may get some rain later, but it's going to be a rainy week off and on.
So that's an example of lower sideband. This again is in the 80 meter band, 3745. Here's an example of the high frequency performance of this Sony CRF-320. I have the Sony hooked up to an 80 meter long wire. So I have both the center conductor and the barrel connector of the coax hooked up to the external antenna jacks on the rear of the radio. Right now we're up at 28.197. So the antenna that I've got hooked up is completely not tuned at this frequency. It's miles off. So let's take a listen to the performance. This is a beacon. So very, very impressive for this receiver. Again, the antenna that's hooked up to the back of this thing is very tightly tuned on the 80 meter band. Miles away. It's actually quite surprising how well this thing receives. Thanks for stopping by the lab today. I hope you enjoyed the repair, modification, and troubleshooting of the Sony CRF-320. If you did, you can let me know by giving me a big thumbs up and hang around. There'll be many more videos just like this in the near future. If you have any questions or comments, feel free to post those below, or if you have any suggestions for future videos, feel free to ask away. All right, see you next time. Take care.